Okay, good morning. Today we are moving into dilations. This is our essential question. How are the image and pre-image related in a dilation? Okay, so we are going to start with this problem. A landscape architect designs two open green spaces for an area of a park. She designs the larger space so the length of each side is 3 times the length of the corresponding side in the smaller green space. Where should the architect draw the larger green space? Okay, so we are going to look at this smaller space here first. Now, what we have to do is we need to redesign this space so that each side is 3 times the length of the corresponding side on the smaller piece. Um, so the first thing, we need to find where, and we need to see how large this is actually going to be. So when we talked about scale factor, we looked at the area of the smaller one, um, the side lengths, how much space it took up, and we multiplied by our scale factor to make it larger. So just looking at this, this is 1/2. If we're making it 3 times larger, we know 1 times 3 is 3. 2 times 3 equals 6. We know it's going to be a rectangle with side length 6 and side width, well, length 3 and width 6. So it can go anywhere in this area right there. What we are specifically going to do today is we are going to be looking at dilating things around 0, 0, our origin, into our coordinate plane. So while there are quite a few places we can place this, we need to specifically look at dilating it so that it runs concurrent with our origin and the pre-image, which is right here. So actually the first thing I am going to do is I'm going to label the vertexes. A, A, B, C, and D. Okay? So I know my new space has to be 3 by 6, but I am going to specifically run from the origin, and I am going to make a ray. So if you remember our activity yesterday, we need to make sure the points dilate through a ray. Our points A, B, C told us that yesterday. So this runs through A right here, and I've gone through 2 sections. So I'm going to go through 2 more, which takes me here, and 2 more, which takes me here. So I am off a little bit. So it has to be a ray. We called it a line segment yesterday, but it is a straight line. So my A prime would be located up here. And then I can just follow my scale factor. I can use my scale factor to draw a new image. So I knew it was 3 down. 1, 2, 3, 4, 5, 6 across. Okay, so if we highlight the different rays that are coming from the origin and through the pre-image, we see that a dilated image vertex, vertices, sorry, must form a ray, which is a straight line, through point of dilation pre-image and image. Okay, so if I am looking at A, so I got A prime here, A here, and the origin here. Notice we have this ray right there. And then the corresponding points D prime, vertices D, and our origin, there is another ray right here. The corresponding or vertices B prime, B, and then our origin, and then our corresponding vertices C prime, C, and our origin right here. Okay, so if we look at our side lengths, we have corresponding side lengths. So I would specifically like to look at this side length B prime, C prime. That corresponds to B and C. Okay, so we talked about our scale factor already. BC is 1 and B prime C prime is 3. And then this is a rectangle, so opposite sides will be the same. Also, we have corresponding side A prime B prime to AB. Those are corresponding. In our pre-image, the length is 2. And as we saw before, in our image, the length was 2 times 3, which was 6. So knowing all these things, what properties of the dilated image are the same as the pre-image? So when we look at properties of images, we have things like the orientation, and we have the size, we have the angle measures. So there are 3 things that are the same. They're facing the same way. All the points are in the same place. So corresponding points have the same location. So the orientation is the same. And this is going to be especially important when we look at like equilateral triangles and squares. You definitely have to not just look at the square, but look at where the points are located. So our A prime and A are both in the top left corner. What else is the same? I'm running out of colors. Is the angle measures. And this is very evident right here. So the measure of angle A is the same as A prime. And the same will be true at D and C, D and D prime, C and C prime, B and B prime. And this is going to be as obviously more evident in shapes that don't have all 90 degrees. You have to pay attention to that. Okay. And the last thing is the actual shape. It is the same shape. They're both rectangles. Okay, so but what is different now? This should be somewhat evident. It is the size. Okay. Remember, in all of our transformations, something changes. Its location, and obviously location is different. Orientation sometimes is different. But in a dilation, the orientation, angle measure, and shape all stay the same. This time we are changing size. Okay, so we've already talked about the scale factor. It's the ratio of a length of an image to the corresponding length in the pre-image. So all right. So we talked about how, so it's a ratio. So we've got something compared to something. So pre-image. Image to pre-image. So I want you to remember this ratio right here. Image to pre-image is equal to R. Okay, so we look at our corresponding side length, AD, AD. So in our pre-image, we use that formula, it's 3. Our image is 1, and that's equal to R. So our scale factor for this one is 3. Something really important about the scale factor also, which we are going to see in the next screen, is from the origin, this ray right here, this length, OB, so origin to B, which is our pre-image, is also going to run the same proportion, OB prime. So OB to OB prime, that scale factor is also 3. So from O to B prime is 3 times the length than O to B. So this also means, I'm going to show you something very interesting here. If we can create a triangle here, and then also a triangle, smaller triangle here, think about our relationships with triangles. The distance from O to B right here, which is 3, should be in proportion the same scale factor. This should be 9 because we have our pre-image multiplied by the scale factor, which is 3, should be equal to the distance away from origin here. And it's true, it's 9. Well, let's see if that holds true in our y-coordinate. So this length right here is going to be 2. So this is just distance right here. So which means that if B's location is 3, 2, B prime's location up here should be at 6, and it holds true. So not only do we have the lengths of the sides in proportion, we also have the length of the ray, and we also have our xy coordinates in proportion. So the location of B, oops, that's too high. The location of B, or the location of B prime, or B prime, should give you a scale factor of 3 also. Okay, we're going to dive into that deeper. Okay, let's look at application of this. So we have F prime over here, that's the orange one. G prime, H prime, I prime is the image of FGHI after a dilation with the center at the origin. Okay. What is the scale factor? So we're not being given the scale factor right now, but we can figure this out. So we have, it's getting larger. Okay, so we know the scale factor is going to be greater than 1. So that's one thing. So R, which is our scale factor, is greater than 1 because our image is larger than our pre-image. I know I'm getting larger. So we have to take the ratio of a side length in FGHI to a corresponding side length in F prime, G prime, H prime, I prime. So let's go ahead and just do the side length F prime, G prime to FG. Okay, so FG is 1. That's on the bottom. And F prime, G prime is 1, 2, 3, 4, 5. 5 over 1. The scale factor is 5. Okay? So when this is written, I want you all to get confused. I want you always to remember The image, we're doing scale factor, is in ratio to the pre-image. So the pre-image is always going to go in the denominator, image in the numerator if you look at it that way. Okay, our next problem, we don't have an image to look at right now. There is nothing on there, but it does give us some clues. Quadrilateral WXY is the image of quadrilateral FGHI after a dilation with center at the origin and a scale factor of 3.5. What are the coordinates of the vertices of quadrilateral WXYZ? So in a problem like this, we actually don't need our coordinate plane because we have a rule that we can follow. We talked about how everything's in proportion, but we do need to redraw FGHI. So that was right here. And this F, G, H. No, that looks like a Q. Just bear with me. I. Okay, so that's our FGHI. So we are dilating, and the scale factor is 3.5. Okay, so what I do know is that WXYZ is going to be 3.5 times as far away from the origin. So our center is the origin. Okay, so I would like to start with point G. So if I take point G, coordinates 1, 1. Point G is going to coordinate with point X, okay? So each coordinate I need to multiply by 3.5 to find the new coordinates for X, okay? So if I do that, 1 times 3.5 is my X coordinate, and 1 times 3.5 is my Y coordinate. So my new coordinates for X are 3.5, 3.5. I'm just going to place that on my coordinate over here. So just about here is going to be my X. Okay, when we look at F, F is at 1, 2. So when F coordinates to W, it's in the same position in the name. So my new coordinates for W are 1 times 3.5 and 2 times 3.5. So my new coordinates for W are 3.5 and 7. And 7 is not on there, but I will try to place it as best as I can. 7 is going to be about here, I'd say. Okay, so that is my W. Okay, so if we look at our completed picture, we're going to follow the same process for Y and Z to find. Just multiply each coordinate by the scale factor to find your new coordinates. So we have our new drawing here, W, X, Y, Z, and we have all our coordinates. We went through W and X, but Y is 7, 3.5, and Z is at 7, 7. The last thing I want you to notice is when I draw rays through the corresponding points from the origin, so F to W, we get straight lines. G to X, I to Z, H to Y. So, and also the length from 0 to F, or the origin to F. If we multiply that by the scale factor, we will get the length from the origin to W. So the scale factor is just all around. Okay, so now we are going to specifically talk about two types of dilations. The first one is the enlargement. And we have spoken about this already. Our scale factor will be greater than 1. Okay. So we have a problem here. What are the coordinates of the image ABCD after a dilation with the center at 0, 0, so at the origin, and a scale factor of 2? So the first step, we're always going to go through steps. This may not always be given to you. So your first step is always to identify the coordinates of each vertex of the pre-image. So A is at 2, negative 2. B is at 2, 1. C is at 4, 0. And D is at 4, negative 1. So we have a trapezoid there. Now, step 2 is to dilate to find the coordinates of the vertices. So we are going to use a scale factor R equals 2. So each coordinate we multiply by 2 to find our new, our dilated image. So we're going to take our pre-image here, A, multiply each coordinate by 2 to find our image A prime, the coordinates. So A prime, 2 times 2 is 4, will be at 4. Negative 2 times 2 is negative 2, or negative 2. We take our B, multiply it by 2 to get B prime. 2 times 2 is 4. 1 times 2 is 2. Look at our coordinate for C. Multiply it by 2. I'm going to do this right here. Times 2, times 2, times 2, which is our scale factor R. 4 times 2 is 8. And 0 times 2 is 0. Please don't get confused when you're multiplying that 0. That will still be along that x-axis, our C prime. D, 4 times 2 is 8. Negative 1 times 2 is negative 2. Like I said, we may not always draw the image. We draw it. But we should be able to get the coordinates of the image from the coordinates of the pre-image and the scale factor. Okay? All right. Okay, and the next type of dilation, of course, is our reduction, so making it smaller. And our scale factor there will be between 1 and 0. Note, if it's equal to 1, the image has not changed at all. So we are going to take our pre-image, which is green, PQRS. We're going to dilate it about the origin with a scale factor of 1/2 to see the image P prime, Q prime, R prime, S prime. So we're going to take the same steps. Step 1, identify the coordinates at each vertex of the pre-image. So P is at 6, 10. Q is at 10, 10. R is at 10, 6. And S is at 6, 6. Okay, so notice 10 is not marked on here, neither is 8. That's just so we can make these clear. Just because something is not marked does not mean you can't figure out what that number is. That's just a side note. So 8, 9, 10. All right. Step 2, dilate to find the coordinates of the vertices P prime, Q prime, R prime, S prime. Multiply the coordinates by the scale factor 1/2. So if we multiply 6, 10 times 1/2, we know that half of 6 is 3 and half of 10 is 5. And let's confirm that in our picture. This is indeed at 3, 5. So I'll mark that here. 3, 5. Q prime. Multiply that by a half. Half of 10 is, whoop, not 10. I'm getting excited. Is 5. And half of 10 is 5. So let's confirm that on here. There's Q prime. It is indeed at 5, 5. R prime. R prime. Multiply R by a half. So each coordinate, half of 10 is 5. Half of 6 is 3. So we have 5, 3 for R. So 5, 3, that is indeed at 5, 3. S prime, so we multiply S by the scale factor, 1 half. Half of 6 is 3, and half of 6 is 3. So indeed, this is at S. This is one of those instances I was talking about where you have to watch to make sure this is a dilation. All of our vertices correspond, so P prime, P, Q prime, Q. They're all in the same location. So it has not been rotated or anything like that, but it has been dilated. Okay, so patterns we should have noticed when dilating about the origin, the location of the dilated figure XY, coordinates are proportional to the pre-image. We multiply the pre-image coordinates by the scale factor to find the dilated image coordinates. This means we do not always need a coordinate plane to solve these dilations. So we have 2 practice problems, and then you guys can do your exit slip. So our first practice problem, we have RS triangle. RST has vertices R, 0, 0, S, 6, 3, and T, 3, negative 3. R prime, S prime, T prime is the image of RST after a dilation with center 0, 0. It's very important. We always look for that center. And a scale factor 1/3. What are the coordinates of point S prime? So we know to find the image coordinates, we need to multiply the pre-image coordinates times the scale factor R. Let me identify these things. We have the pre-image coordinates R, S, T. We have the scale factor. It's given to us. It's 1/3. 0, 0 of R. We multiply by that scale factor, which is 1/3, and we get R prime at 0, 0. Let's go to S. We have S is at 6, 3. So we're going to take 1/3 of each of those coordinates, multiply by 1/3. Our S prime, 1/3 of 6 is 2, and 1/3 of 3 is 1. And our last coordinate of T, we are at 3, negative 3. And we're going to multiply that by 1/3. So our T prime, 1/3 of 3 is 1. 1/3 of negative 3 is negative 1. That's it. This is our solution. It's asking for the coordinates. You have found the coordinates. That's it. Okay, our second practice problem. We now have a rectangle, QUAD, has coordinates Q 4, 5, U 4, 10, A 11, 10, and D 11, 5. Q prime, A prime, Q prime, U prime, A prime, B prime is the image of QUAD after a dilation with the center 0, 0. So it's very important that we make sure we can do these with the center 0, 0 and a scale factor 5. What is the length of segment QU? Okay, so this time we're not actually going to find a dilation. So we might take a different step this time. So F, so the length of Q prime, U prime, is going to be equal to the length of QU times the scale factor, R. And we have the length of QU, and we have R. Okay, so QU let's do this over here. Q and U are along the same x coordinates. So the difference is going to be in the y coordinates. So we're going to take Q of the y. We're going to do the absolute value of this minus Q times the U. And that will give us our length. So 5 minus 10, but we're going to take absolute value because it's length. Absolute value of -5 is 5. Okay. So the length of QU is 5, and we're going to multiply that by the scale factor R, which is 5. So the length of Q prime, U prime, is 25. Okay. So you have to do the exit slip, which is on Schoology. And then come prepared to work today. I'm going to give about 20 minutes for math, and then the rest of the time we're going to spend on our science test review.